Hi, I'm Sam Hoare from Pharmacanics. In this video, I'm going to describe a new approach for measuring drug activity in signaling assays. We will see how this provides new insights for drug discovery by reassessing biased agonism of antipsychotic drugs. The approach evaluates the kinetics of drug effect. In other words, we measure the response over time. This is now being done routinely using biosensors of signaling, which emerged from new technology for measuring signaling in real time. What we need to do now is to convert the time course data into drug parameters that we can use to optimize new therapeutics. At Pharmacanics, we developed a data analysis framework that enables you to do this. We did this using the framework of enzyme kinetics. As you will remember from school, the enzyme converts a substrate into a product, and this happens at a certain rate called the Vmax. For signaling systems, we can substitute the enzyme for receptor and the substrate for G protein. The receptor generates active G protein from the inactive G protein substrate. This generation proceeds at a certain rate we call the kinetic efficacy, and this is termed k-tau. This is simply the rate at which the agonist stimulates the response. Now we're going to apply this idea to drug discovery. A recent well-known study from Monash University and the University of Nottingham showed that biased agonism is dependent on the time you measure it. In other words, we need to consider the temporal pattern, that is, the shape of the time course, in order to understand the pharmacology. This was shown for a series of dopamine receptor ligands, including antipsychotics such as aripiprazole. Here are the dopamine time course data for 4 of the pathways the authors evaluated: G protein, ERK, cyclic AMP, and arrestin. The authors kindly provided the raw data as a supplement to their article. At Pharmacanics, we have derived equations that you can use to analyze data like these to determine the kinetic efficacy. The shape and the equation is dependent on the underlying mechanism, which I can go through with you offline. The data analysis is straightforward. We take the raw data, fit the equation to it in a program like Prism, and this gives us the fitted value of the kinetic efficacy, in other words, the k-tau value. Here's the fit to the bell-shaped ERK data, and here is the fit to the cyclic AMP data. Note there are 2 components to the cyclic AMP response, one being the fast peak response and the other being the prolonged plateau. This peak and plateau model also applies to arrestin recruitment. Now let's go through the k-tau kinetic efficacy values. This is a radar plot where the corners are the different signaling pathways. Here are the data for dopamine. The k-tau values are all normalized to those of dopamine, so these values are all 100%. Here is ropinirole. The compound is similar to dopamine, except for the arrestin plateau, where the kinetic efficacy is reduced to 63%. For bifeprinox, you can see the shape is skewed towards the right, which is where the G protein signaling pathways are. This indicates the compound is biased toward G protein over arrestin. As we go down the list of compounds, the shape stays roughly the same. This indicates the signaling bias is roughly the same. The area gets smaller, indicating the compounds have lower and lower kinetic efficacy. Now let's bring in aripiprazole. Strikingly, the shape is different. This is because aripiprazole is a full agonist for recruiting arrestin at the plateau. This means that it stabilizes a conformation that strongly couples to arrestin over the long term. Let's put these data in context. Aripiprazole is reported to be only a weak partial agonist for arrestin recruitment, averaging at about 20% in short-duration experiments we use in drug discovery. By contrast, the kinetic efficacy value indicates that in the long term, aripiprazole is fully effective for recruiting arrestin. This long-term response is likely more relevant because the drug works chronically. As you may know, it has been proposed that arrestin recruitment is beneficial for antipsychotic efficacy. If this is the case, we could use kinetic efficacy for identifying compounds that produce a prolonged recruitment of arrestin. The k-tau values also show that aripiprazole is biased away from G protein. This could be beneficial to reduce motor side effects that are mediated by G protein signaling. In summary, we have gone through a new kinetic method for quantifying agonist efficacy. We recently published this method, including work we did with Cisbio and Biotech, and there are lots of links in the comments. Please contact me if you would like more information, and check out our website to see how we can help you to analyze your data. I'm Sam Hoare, and thank you for watching this presentation.